Let's go ahead and go over the unit review. Hopefully this is just you checking your answers and that you've attempted all of these, and if you get any wrong or you weren't sure about any, this should answer the questions that you have. Section 1 is going to deal with theoretical versus experimental probability. First thing we're asked to find is what's the probability of an integer. For number 1, we look at our spinner to the left and we notice that we have 5 integers. The integers are 36, 1, -6, 25, and 100. So therefore, we have 5 integers out of 8 sections. If you want to convert it to a percent, go ahead, but I didn't bother doing that. Number 2 says find the probability that you will land on a perfect square. So when we look at this, there's 36, there's 100, there's 25, and there's 1. Therefore, that leaves us with 4 out of 8. If you want to make that 1/2, that's fine. But you can leave it as 4 out of 8 for the theoretical probability of landing on a perfect square. For landing on the irrational number, there is only one of them. That is pi. So that's 1 out of 8. Number 4, a composite number, meaning you can multiply more than just 1 in itself to get that number. And there are 4 of those. 36, 100, 25, and -6. So that's 4 out of 8. And again, if you want to simplify it to 1/2, go ahead. Number 5, the probability that it is not a whole number. So when we look at this, there's pi, there's -6, there's 1/3, and 0.5. So that's 4 out of 8, or 1/2, or you could do 50%. That are not whole numbers. Now, the last one is one of those independent events where we're going to do 2 things. So first we're asked to find the probability of an even number and then a rational number. There are 3 even numbers out of 8. That's 36, 100, and -6. And we're asked to multiply it by we then need to multiply by how many rational numbers there are. Well, there are 7 out of 8 that are rational. In number 3, you found 1 irrational. That means there are 7 that are rational. So we end up with 21 out of 64. For the next section, a survey asked 500 teens what formats of music they listened to in the past 2 months. The results are that 180 listened to Pandora and 320 listened to music on iTunes. So for number 7 says, what's the experimental probability a teen listened to Pandora in the past 2 months? That would be 180 out of 500. Because 180 out of the 500 listened to Pandora. What is the experimental probability a teen listened to their iTunes library in the past 2 months? 320 out of 500. The reason those are experimental probabilities is because they actually talk to people. The theoretical probability for both would be 1/2 because you have an equal chance of picking one or the other. For number 9, 225 6th graders were asked to name their favorite cafeteria lunch. 135 students named pizza as their favorite. If an additional 80 6th graders were asked, how many would be expected to choose pizza? So they tell us that 135 out of 225 chose pizza. If we add 80 more to the 225, that gives us a total of 305 students. So what we want to know is how many out of the 305 would choose pizza. When you solve that proportion, you get 183 students. In number 10, in her last 30 serves, Megan served the ball over the net 18 times. Based on this, how many of the next 50 serves should she expect to go over the net? So we know that 18 out of 30 were successful in going over the net. So how many out of 50 could we expect, or could she expect? She could expect it 30 times. So the answer is 30 serves. Now into geometric probability, which is the area that most students struggled in when you took the quiz. So looking at number 11, a dart thrown will land in the shaded region. So I gave you that the total area was 184 meters squared because most students haven't learned the trapezoid formula yet. So the first thing we have to do is calculate the middle part that is not shaded. So if we're calculating the rectangle, that's going to be 14 times 8, and we get 112 meters squared. And therefore, to find the shaded, we have to say the total area minus the unshaded, which gives us 72 meters squared or shaded. Therefore, 72 out of 184 is your chances of it landing in the shaded region, which is approximately 39.13%. For the second one, we want to know what's the probability that the object will land in the white region or the unshaded region. So the first thing we're going to do is we're going to deal with the rectangle, which is 300 times 150, which gives us 45,000. Units squared. We have the square, which is 100 times 100, which gives us 10,000 units squared. And we have the triangle, which is 120 times 500, times 150 divided by 2 or times a half, and the triangle gives you 9,000 units squared. Therefore, to get the shaded region, the unshaded region, we take our whole area of 45,000 and take away 10,000 for the shaded square and 9,000 for the shaded triangle. And that's going to leave us with 26,000 units squared for the unshaded part. So when we go to do our probability, we're comparing 26,000 over 45,000, which is approximately 57.78%. On to the last one. What is the probability a golf will land on the green? Now, the green is an abnormal shape or an irregular shape, so they went ahead and gave you the full area of the green as 1,800 feet squared. So the first thing that we have to do is calculate the area for the not green, which would be 50 times 60, which is going to give you 3,000 feet squared. We know that the shaded region is 1,800 square feet, and the total area is 3,000 square feet, so we end up with 60%. Now, section 3 is asking about modeling outcomes. So we are asked to make a model for each of these. Number 14 says make an organized list to determine the number of one bread and one beverage outcomes using the breakfast choices listed. So our sample space would be, we could do toast with coffee, we could do toast with milk, and we could do toast with juice. We can do a muffin with coffee, we could do a muffin with milk, and we could do a muffin with juice. We also could do a bagel with coffee, a bagel with milk, and a bagel with juice. Notice that I used M for muffin, but MI for milk Makes the list a little easier to read. So we were asked to make a list. The list represents the sample space. And when we add it up, we find out that there are, in fact, 9 outcomes. Number 15, a family of 3 plays bingo at home every night. Each night, the chance that Denise, Kemp, or Ashley will win is 1/3. Draw a tree diagram that shows the possible outcomes for 2 consecutive nights of play. Is the probability that Kemp wins both nights the same as the probability that Denise wins the first night and Ashley wins the second night? So let's go through and do our tree diagram. So the first night, Denise could win, or Kemp could win, or Ashley could win. So that's for the first night. Now, when you go to do the second night, if Denise wins the first night, Denise can win the second night, Kemp could win the second night, or Ashley could win the second night. So we could have Denise, Denise, Kemp, or Denise, Ashley. If Kemp wins the first night, Denise could win the second night, Kemp could win the second night, or Ashley could win the second night. So we could have Kemp, Denise, Kemp, Kemp, or Kemp, Ashley. If Ashley wins the first night, we can have Denise win the second night, Kemp win the second night, or Ashley could win the second night. So therefore, we could have Ashley, Denise, Ashley, Kemp, or Ashley, Ashley. In this case, we count the repeats because we're dealing with 2 separate nights that order matters. So this represents our sample space. If we were to make a list, we would say DD, then DK, then DA, then KD, then KK, then KA, then AD, then AK, then AA. So we look at this and we see, hey, there's 9 outcomes. Because there's 9 possible ways for it to go for people to win the 2 nights. And the list shows our sample space. Now let's answer the question. If the probability that Kemp wins both nights, so that Kemp wins both nights, that's a 1/9 chance. And it wants to know, is that the same as the probability that Denise wins the first night and Ashley wins the second night? Well, there's only 1 out of the 9 that is true for Denise and then Ashley. So therefore, yes, they are equal. If you have more space, you can say, yes, the probabilities are equal, but I'm writing really big on here, and so I don't have the space. Okay, and then number 16 says, draw an area model to find the sample space. A spinner with equal sections labeled A, B, and C is spun. And a number cube is rolled. Now we know that the number cube has the numbers 1, 2, 3, 4, 5, and 6. So when we go to fill in our possibilities, we have A1, A2, A3, A4, A5, A6, B1, B2, B3, B4, B5, B6, C1, C2, C3, C4, C5, C6. So now that I've just gotten done sounding like a caller at a bingo game, the blue numbers are your sample space. That is your list. When we put it in the area model, I put A, B, C on the side and 1 through 6 on the top. You can do it in reverse, that's fine. So now there's our area model. Our sample space is the blue. We're asked to find the probability of spinning a B and a 3. Well, if we look, there is only one out of 3 chances that you're going to roll a B. And there is only 1 out of 6 chances that you'll roll a 3. So you end up with 1 out of 18 possibilities. You can also count that there are 18 possibilities and only one of them is B3. So we want to find the probability of spinning a vowel and rolling an even number. Well, if we spin a vowel, there's only 1 out of the 3 that's a vowel. And an even number, that's 3 out of the 6 that are even, which gives us that 3 out of the 18, or 1/6, are going to give you a vowel and an even number. And if we look, A2, A4, and A6 in our sample space, or the list, are the only options to meet those criteria. Section 4 is talking about the fundamental counting principle. So that is pretty much what I did for A and B. Regina has 3 necklaces, 3 pairs of earrings, and 2 bracelets. How many combinations of the 3 types of jewelry are possible? The answer is 18 combos. Number 18, Julie is getting ready for school. She can choose from 3 pairs of jeans and 5 blouses. How many outfits can Julie create if all of the combinations coordinate? And the answer is 15 outfits. So it pretty much says that if they all match. Number 19, Brian has homework in math, science, reading, and art. He plans on doing math homework first. List the number of ways in which he can complete the 4 homework assignments. So we know he's doing math first. Then he's going to do science, and it asked us for a list, and then he can do reading, and then he can do art. Or he could do math and then science, but then do art and then reading. Or he could do math, reading, then science, art, or math, reading, art, science. Or he could do math, art, reading, science, or math, art, science, reading. This means that there are 6 ways. Because he's doing math first, he can only do it 6 ways. On to the final question. 5 band members play the flute. In how many ways can these members be chosen for first, second, and third chairs of the flute section? So if we look at it, there are 5 possibilities to get that first chair. To get second chair, that leaves us with only 4 possibilities. And to get the third chair, that leaves us with 3 possibilities, meaning 2 people are left out. And so that's how you end up with 60 ways. On to Section 5, independent versus dependent events. If you have a standard deck of cards, what is the probability of picking a diamond? So that's 13 out of the 52 times. You then want to replace the card. This means that the total of 52 has not changed. And we pick a 2, a 5, or a 9. Well, there's 4 2s, there's 4 5s, and there's 4 9s. So that means that's a total of 12. And that gives us 156 out of 2,704. Again, the reason we did 52 as the denominator in both is because we put the card back so the total changed. 22, when using a 6-sided number cube, what is the probability of rolling a 3? So there's 1 out of 6 sides that are a 3. And then rolling a 3, so we still have 1 out of 6 sides that is a 3. Oh, excuse me. What is the probability of rolling a 3, then not rolling a 3? So not rolling a 3 means it's 5 out of 6. And then rolling an even number, which is 3 out of 6. Because 3 out of the 6 are even numbers, 5 out of 6 are not 3s, and 1 out of 6 is a 3. And this gives us 15 out of 216. If you want to convert any of these to percents, feel free, but you don't have to. 23, Channing has 10 cards numbered 1 through 10. What is the probability of picking 2 even-numbered cards, one after another, if the first card picked is replaced? That means the total will not change. So 5 out of the 10 are even, and it's put back. So we still have 5 out of 10 that are even, giving us that it's 25 out of 100. Chance that you would pick 2 even-numbered cards replacing the first. 24, a bag contains 4 red, 20 blue, and 6 green candies. Omar picks one at random and keeps it. Then Jade picks a candy. What is the probability they each selected a red candy? So Omar picks a red candy, so that is 4 out of 30. And he liked the red candy, so he kept it. That means for Jade, there's only 29 candies. And since Omar took one of the red, there's only 3 left. So we end up with 4 over 30 times 3 over 39, which is 12 over 870. In any of these cases that you want to simplify these, feel free, but you do not have to. You are also able to convert them to percents if you want, but you do not have to. 25. A basket of candy contains 2 grape, 3 orange, and 5 cherry candies. The candy is not replaced once selected. Find the probability, or find each probability. So picking 2 orange. So that would be 3 out of 10. But we like the orange, and we kept it. So that means that there's now 9 candies, and there's only 2 remaining oranges. So we end up with 6 out of 90. The probability of picking grape then cherry. 2 out of the 10 are grape. We liked that grape, so we kept it. So now that the denominator is going to stay 9. And there are 5 cherry candies. And so we end up with 10 over 90. An orange and then a grape. Well, we start off with 3 out of 10 that are orange. We like that orange, so we kept it. So that means that there's now 9 candies in the bowl, and 2 of them are grape. And we end up with 6 out of 90. So to be clear, the first 3, 21, 22, 23, were all independent events because we replaced things. What happened the first time didn't affect the second one. Whereas 24 and 25 are dependent events, along with 26, which we'll do in a minute, because what I did first affected what happened the second time. 26. Ms. Lewis cut up letters in the word Missouri and pasted them in a bag. Suppose you do not replace the first letter before drawing the second. What's the probability of drawing an M and then drawing an I? So we know that there's 1 out of 8 letters that are M's. We did not replace it. This means it's a dependent event. There's 7 letters left because we picked an M. And of those 7 letters, 2 of them are I's. Therefore, the probability would be 2 out of 56. And then on to our final section. Andy has 20 tangram pieces in a bag. 1/5 of the tiles are rectangles, 40% of the tiles are trapezoids, and the rest are triangles. Andy chooses 1 triangle from the bag and then gives the bag to her friend Amy. If Amy takes 1 tile from the bag without looking, what is the probability that the tile she chooses will be a quadrilateral? Well, the first thing we have to do is figure out how many tiles are rectangles, are trapezoids, and therefore triangles. So to do this, we're going to start out by saying 1/5 times 20, because we want to know how many are rectangles. And that tells us 4. So we now know that there are 4 rectangles. And then for 40%, we have to do 40 over 100 equals x over 20. Or we can do 0.4 times 20. and we end up with 8. So there are 8 trapezoids. And therefore, if there are 20 tiles total, and 4 are rectangles and 8 are trapezoids, this leaves us with 8 triangles. So now, Amy chooses one tile. Oh, Andy chooses one triangle. So that means there's only 7 triangles left. But it also means there's 19 in the bag. Amy takes one tile from the bag without looking. What's the probability she chooses a quadrilateral? Rectangles and trapezoids are your quadrilaterals. Therefore, you end up with 12 out of 19, which is about 63.16%. Feel free to convert it if you want, or you can just leave it as 12 over 19. Marcus placed 8 blue tiles and 12 red tiles in a container. He plans to draw a tile, record its color, and then replace it in the container before drawing another. If he does this 50 times, how many times should he expect to draw a red tile? So if we look, there are a total of 20 tiles. I got 20 by saying 8 plus 12. So that tells me the total is 20. So there are 12 out of the 20 that are red. And I want to know how many out of 50 could he expect to draw. When we cross multiply and divide, we find out that he could expect to pull a red tile 30 times. But we know that the likelihood of that is unlikely because of the lower number, and experimental and theoretical don't always line up. 29, Claire tosses a coin and then rolls a number cube 100 times. How many times could she expect to have a coin show heads and roll a 1 or a 2? So she tosses the coin, and we're asked about heads, so that's 1/2 for the coin, times, we're then asked a 1 or a 2, that's 2 out of 6. Therefore, she has a 2 out of 12 chance of getting a coin and a 1 or a 2. Now, we are asked to take this a step further and said, if 2 out of the 12 times will be a coin showing heads and a roll of a 1 or a 2, how many out of 100 times would that be? And the answer is about 17 times. Because it doesn't work out evenly, so we have to get a little creative and we're going to have to round.